Assalamu alaikum. Welcome to the next lecture. In this lecture, we are starting with a new unit, and we'll start from the features of the power supply to the domestic consumers. Or in general, we can see what are the different features of the power that has to be supplied to the consumers. Such type of power usually is known as quality power, and quality power has some different properties. What are different properties? The first one being that the voltage magnitude should be fixed. We can allow a plus minus 5% deviation from full load to no load. That means the allowable range of the voltage can be admitted to 209 to 231 volt if the rated voltage is considered to be 220 volt. Similarly, we should have a fixed frequency voltage. Its frequency should not vary. In this case also we may allow a plus minus 1% deviation from no load to full load. We can see that the frequency may change from 49.5 to 50.5 Hertz for a 50 Hertz system. The supply voltage should have an acceptable, or we can say minimum THD. THD means total harmonic distortion. Actually this THD is related to the wave shape of the voltage. The wave shape of the voltage should be very close to the sinusoidal wave shape. As we have discussed in the AC analysis, the wave shape we have considered to be the sinusoidal, but sometimes it may not be sinusoidal, it may be slightly distorted, but that distortion is also acceptable to some permissible limits that should be less than that of the permissible limit. Usually limit is also kept to 5%. It should be less than 5%. The supply should be reliable throughout the time. That means the supply should be available throughout the time. There should not be any load shedding or power cut, untimely power cut. Voltage fluctuations should be minimum. The continuous voltage fluctuation that we might have encountered or experienced, such voltage fluctuation, they should be minimum. There should not be any voltage fluctuations. Voltage should be constant. So these are the features of our supply to the domestic consumers, and actual agreement is based on these type of the properties of the voltage, or we can say supply voltage. In general, they are, or we can say in combination, when such type of supply has got such type of the properties, we know that such type of system has the quality power. Now, safety measures in electrical circuits. Before installing any electric circuit, or when you use an electrical equipment or circuit or appliance, you should be able to uh, run them safely, because electricity is also accompanied with some hazards, or we can say with some problems. If safe practices are followed, many electrocutions and home fires can be avoided. Electrocutions means when electric shock is given to a person and it may result in his death, we can say that person has been electrocuted. And home fires, you know that whenever there is a short circuit, there is a possibility that it may result in a short circuit. So proper safety practices, or if you take the safety measures, you will avoid such type of problems. So you need to make sure that all the metallic parts of electrical equipment are effectively earthed, and we'll come to know shortly why do we earth the equipment. So this earthing will provide us a good amount of safety measure. Broken switches, plugs, etc. should be replaced immediately, because they may result in the overheating, and finally it may result in the fire. Use a linear tester to check whether the terminal is live when you do some sort of testing or repairing or maintenance. So linear tester will be a good thing to use, because you'll be able to understand which wire is live and which wire is a neutral wire. Before replacing broken switch, put off the supply. So you should, irrespective of the thing, if the broken switch, you should put off the supply before replacing it, because you will avoid having any electric shock. Never use equipment and appliances with damaged lead wires. Lead wires should be healthy; they should not be damaged. Again, they may result in some electric shock if somebody may touch them, and if other wire may come in contact with this damaged wires. It may result in electric shock, electric short circuit. Never use a bare wire in the holes of socket for taking connection. Always use a proper plug. So you should avoid such type of practices. Use rubber sole shoes while repairing or testing electrical equipment so that your body is not in direct contact with earth. You may sometimes use some wooden shoes as well, or some wood piece that's placed under your feet where you are testing or repairing some electrical equipment. Use rubber gloves while touching any terminal, because this may, even if the terminal is at any potential or have some live voltage, you may be saved from that. Always use the well insulated tools like plier, like screwdriver. They should be well insulated. Never touch two different terminals at the same time, because they will complete the path through your body and you will get electric shock. Use correct rating fuse wire or MCB. So this should be or MCB, because in that case, if you use a fuse of lower rating, it may get burst or it may fuse before you get the actual power. Or if you use a fuse or MCB of higher rating, it may not be useful of tripping when there is a short circuit. So you need to have a proper rating of fuse and MCB. While repairing an electrical appliance, be sure that the plug has been taken out from the socket. You should not only put out by switching off the socket. You should take the plug, to be on the safer side. You should take the plug out, so that if the switch may have some problem while switching it off, you will not get any electric shock. Never try to connect machine to a voltage supply other than the rated one, because machines or equipments have some voltage rating or other ratings. So for example, if we have a toaster, it is usually rated for 220 volt. If we use 440 volt, it will get damaged. So we need to use the machines or equipments, and we have to supply them the voltage for which they are designed or for which they are rated. Strictly follow all the precautions and instructions given on the nameplate of the machine you are working on. You can see these points are two connected to each other. That you should first, whenever you buy any electrical equipment, you should first try to read its nameplate, and you will get an idea from the nameplate how the rated quantity are to be calculated and how the rated quantity are to be manipulated during the working hours. As I have told you, the rating voltage of the electrical toaster will be given, let us say it is 220 volt, and it is given in its nameplate. So you have to use the voltage accordingly. You cannot use a voltage higher than that. It may result in the damage of the same. Avoid overloading of electric circuits to avoid fire hazards. We should avoid such type of overloading. Home appliances should be regularly inspected for damaged plugs, switches, and cords, because in that case they have a tendency to result in the fire. So if they are found faulty, replace or repair them immediately. All the connection that you made should be proper and electrically tight. This is very important, because you will see that the first weakest point of the electrical circuit is the loose connection. Whenever it is a loose connection, it results in sparking, or it results in high resistance and heating, and due to which a continuous heat will result in the burning of that wire, and it may ultimately lead to the fire. So it is very important to do the connections very tight, and they should be proper with respect, proper in the sense with regard to the circuit. Now let us come to the main topic, that is the earthing. So it is one of the important thing, and the prime motive of the earthing, as I have told you in the safety precaution, is the safety of the personnel and safety of the equipment. So need for earthing, as you can see, that to ensure safety of the life and property from the hazards of electrical shocks and fires. Electrical shocks will be experienced by the person. That's why we can see and ensure the safety of the life, and fires for property, we can ensure the safety of the property. To ensure the system voltage on healthy lines to remain within reasonable limits under the faulty condition, therefore preventing insulation breakdown. Actually, we are not going to in detail with this point, but I will try make you understand here. In case of unearthed system, if the fault occurs, the voltage of other phases of a three-phase system may increase, which may result in the breakdown of insulation between the lines, and it will result in a three-phase short circuit, so which is a very high, very dangerous condition. So when we do the system earthing, the voltage of the healthy lines, whenever a single line to ground fault occurs, or we can see one when the fault occurs on one phase, other phase voltage remains as their own value. So in that case, there will not be any voltage breakdown. To provide the low impedance part to facilitate the satisfactory operation of the protective device and the fault conditions. When the fault condition occurs and we know that the system is earth, there will be a fault current that flows through the earth, and this current has a value, very high value, and in that case it will be very easy to detect such kind of fault condition, and we can then separate such type of circuit from the actual system so as to avoid the damage. So this is one more important advantage of this. So the over voltage due to lighting are discharged to the earth. We can use earth to discharge the lighting over voltage to earth. This is one more important advantage. But here, among these four points, we may be ensuring, or we may be having more emphasis on the point one, to save the life and property from the hazards of electrical shock. You can use the same earth at your home uh, just to discharge the lighting over voltage to the earth. In that case, your home will be safeguarded. Now, what is earthing? It is the process of connecting the metal frame, or we can say casing, in which we are putting the electrical machines, and that is usually known as non-current carrying part, because you will see that the casing of any equipment will not carry any current during the normal operation of the system. Of electrical equipment, of electrical part of the system, for example, neutral point in a star connected system, one conductor of the second of the transformer, etc., to the earth, is known as grounding or earth. So here we have mentioned actually two parts. One is the non-current carrying conductor of the electrical equipment, or some of the electrical part of the system, which is the neutral point in the star connected system, which we have already discussed, or one conductor of the secondary of the transformer, etc. When they are connected to the ground, we say such type of process is known as grounding or earthing. In general, it is known as grounding, but sometimes the grounding and earthing are separated by, or we can say they are distinguished by a minute difference. I will let you know what is that minute difference. Now, if the grounding is done systematically in the line of power system, we can effectively prevent accidents and damage to the equipment of the power system, and at the same time continue that the supply can be maintained. This is a very important point, because when this is done, as I have told you, that accidents can be prevented by, when the fault is detected, it can be then isolated, or we can see first the faulty part of the system is isolated by opening the circuit breaker. Okay, so in that case, you can see the system equipments can be saved from the damage, and the personals can also be saved from the life threat. There are two types of earthing. We can say it is grounding or earthing. We know that grounding earth may be classified as equipment grounding or earthing in general, and system grounding. This system grounding is known as usually neutral grounding. We are more concerned here the equipment grounding. System grounding, I may give a glance of this system grounding or neutral grounding. Equipment ground deals with the earthing the non-current carrying metal parts of the electrical equipment. You can see that we are just connecting the casing in general, we can say, to the earth. On the other hand, the system grounding means the earthing some of the parts of electrical system. For example, earthing the neutral point of the star connected system in the generator station and substation. Usually there are two things that we usually connect to ground in case of neutral grounding or system grounding. One is the star point of the star connected transformer or generator, and another is the, if we have a single phase transformer, the secondary and the primary of one of them are connected to the earth. Now we'll start from the equipment grounding. It is the process of connecting non-current carrying metal parts that we had just discussed. That is a metal enclosure of the electrical equipment to earth or soil. Usually earth means we're making earth in such a way to behave as zero potential, and we need to have some certain method of doing that. We'll discuss that as well. For the time being, we can directly connect them to earth, and we say that we have done the equipment grounding in such a way that in case of insulation failure, the enclosure effectively remains at earth potential. In that case, it is called equipment potential. Sorry, equipment grounding. So this is done so that whenever the short circuit of insulation failure occurs, in that case, this enclosure should be effectively remains at earth potential. In that case, this is then the efficient equipment grounding. So in the interest of easy understanding, we shall divide the discussion into three heads. One is ungrounded enclosure connected to neutral wire, and ground wire connected to enclosure. Let us discuss this. Let us say we have a generator, we have the transmission line over, or we can say the simple wires over here. We have a machine or a motor. This resistance is actually a fictitious resistance between this motor and its casing. So normally its value is very high. There will be no current, or we can say very small current flowing through this point and this point through this resistance, and that current will flow through this part to the earth, because in this case this is not connected to ground. This casing. We can say that in normal operation of condition there may not be any current flowing through this. So whenever this is a person, and a person has its own resistance, and electrically it can be shown by a resistance. When it touches this metal casing during the normal operation of this motor, there will be nothing happening to this, because this resistance is very high. The resistance of the human is of the order of kilo ohm. There will be practically no current flowing through the human, and it will experience no shock, and it will be quite safe for this. But during the abnormal operation, you will see that this resistance will be very small, or we can say that there will be insulation breakdown, because you will see that there will be some insulation between this and this. That insulation is provided by the air, and air has got a good amount of insulation. When there is an insulation breakdown, or we can say high voltage appear across this, and it breaks down the air becomes conducting. When air becomes conducting, this resistance becomes very small. We can say that the potential at this point will be as same as the potential at this point. Now this human is touching this casing with the potential, high potential, and you will see that since it may be barefooted on the ground, the current will flow like this, and then back to this. And in this case, this is very dangerous to the human being. So when this type of situation occurs, it may result in the damage, or we can say death of the human being. So one more insulation failure we can think of, that this winding may be connected, or this point may be connected due to abnormal condition to this point, and in that case it will result in high shock. So what is the remedy of this case? The remedy is that enclosure connected to the neutral wire. When this enclosure is connected to the neutral wire, during the normal and abnormal conditions, there will be no current flowing through the human being, and we can say that humans or a person will not experience any shock during any condition, whether it is normal operation of condition or this abnormal condition. But sometimes if this neutral wire is open circuit and then insulation breakdown occurs, you will see that the same condition occurs which was the case when this was not connected to this wire. So in that case, again the current will flow through this path, and through this path, and again this person will experience a shock, and it may result in its death. So in that case, this is also very dangerous. So to avoid these things, we can use one more wire like this from casing to this, that is known as ground wire, apart from the neutral wire. So in that case, whether we have a normal condition when this is switch closed, whether we have an abnormal condition and the fault occurs and the switch is open, where the faulty current will close its path through this circuit. It will not close its path through this circuit, and in this case you will see that the person is safeguarded. So to get rid of this, we install a third wire called the ground wire between the enclosure and the system ground. The ground wire may be bare or insulated. Usually it should be insulated in the homes, and you will see that it will always be insulated. When it is insulated, it is colored in green. Electrical outlets have three contacts. You will see that we have three contacts in electrical outlet. One is for live, another for neutral, and for ground wire. So this is for the safety purpose, and this is the extreme condition, and we are here covering that extreme condition as well, worst case condition as well. In that case, even if that occurs, a person will be always safeguarded. So that's why we have always three terminals of a single phase system. Now coming to the system ground, let us say we have an 11 kV line and we have a transformer. This is the primary of the transformer, this is the secondary of the transformer. So the primary voltage of the transformer is 11 kV and the secondary is 230 kV. That is the actually distribution transformer. So let us assume that we don't have any we don't have grounded these terminals to the we don't have connected these terminals to the ground. We don't use the system grounding. A fictitious capacitance occur between the two windings and this winding and ground. Due to this capacitance that occurs between this winding and ground, a high voltage will appear across this. Because a current will flow through this, path will become, and the voltage, that current multiplied by the reactance of this, will give us the voltage. That voltage will be of this order. And when a person touches this point during this condition, when this is not this point is not grounded to the this earth, you will see that this much of voltage will appear across them and it will result in the instant death of the person. And when this point is connected to the ground, you will see that this voltage will become zero, and when a person will touch this point, you will see that only 230 volt will appear across him, and very small current will flow through its body, and the person may be safeguarded. And in the grounded case, if it touches the point 2, there will be no voltage across the person, and there will be no current flowing through them, and it will be saved. And in the worst case condition, when the fault occurs, you will see that an ungrounded system, that fault occurs, this voltage will be directly at this point, and that voltage will be appearing across this person, and a huge amount of current will flow through him. So in that case also, you will see that an instant death will occur to this person. When the system is grounded, or when this 2 point is grounded, connected to ground through the ground wire, and even if a person touches this wire, you will see that the path will become like this and the person is safeguarded. This is the general introduction of the system grounded. Now let us come to the safe currents through and the resistance of the human body. We'll see that what will is. It is generally believed that currents below 5 milliamperes are not dangerous. Between 10 milliamperes and 20 milliamperes, the current is dangerous because the victim loses muscular control. The resistance of the human body taken between two hands or between one hand and a leg ranges from 500 ohm to 50 kilo ohm. If the resistance of human body is assumed to be 20 kilo ohm, then the momentary contact with 230 volts line can be potentially fatal. So you will see that the current flowing through the human body will be this 230 divided by 220 kilo ohm. It will be of the order of this 11.5 milliampere, which may be in this range, and it may be potentially fatal to the human body. Brunner in 1967 stated that the threshold of a perception of electrical short is about 1 milliampere. When the current goes beyond 1 milliampere, then afterwards a person may be able to sense the electric shock. With an increase in the AC current, a sensation of tingling gives way of contraction of muscles. It results in the contraction of muscles. The muscular contraction increases as the current increases, and final value of the current is reached. Finally, the value of the current is reached a value at which the person cannot release the grip on the current carrying conductor. In that case, it will remain in touch with this and it will not be able to release the grip of the conductor. So the maximum current at which the person is still capable of releasing the conductor by using the muscles directly simulated by the current is known as let go current. Or we can say this is the current up to which the person is able to release the conductor from its hands, and beyond this it will not be able to release that. And the let go current, we can consider this let go current to be the current up to which we can say a person may be safe. Based on the experiment conducted on the males and females, it is generally expected that the safe let-go current should be taken approximately 9 milliamperes and 6 milliamperes for men and women respectively. That means 9 milliamperes for men and 6 milliamperes for women respectively. Now coming to types of earthing, how do we actually do the earthing? In case of our home substations and other things, how do we do the earthing? There are usually four types of earthing. One is pipe earthing, plate earthing, strip earthing, and rod earthing. So let us first discuss the pipe earthing. Galvanized iron pipe 30 mm in diameter and 2 meter long. It's also known as GI pipe, 2 meter long, or a copper plate of adequate size buried edgewise into the earth is used as earth electrode. That means earth electrode is used, this galvanized earth pipe, and then it is connected to this. Again, this is an GI pipe through this connection. Its resistance must be kept below specified limit. It should be very low, of the order of 1 ohm or 0.5 ohm or even 1 or 2 ohm. Baker percentage salts and powdered coke or charcoal to a depth of 30 centimeter all around the pipe. What is to be done? In this case, you can see from here to here is the salt filled structure. We have charcoal filled over here, and we may have a coke filled over here. In this case, when this happens, the resistance of the soil will decrease. The resistance of pipe ultimately will decrease. Low resistance is kept by the moist earth. This earth is kept moist by pouring the water into the pipe. In that case, the resistance will be slowed down, or we can say it will be decreased. When this happens, you can see this connection, this is the earth wire, and then earth wire can be taken to anywhere, or we can say the three terminals of the plug can be connected. The third, that's the green wire, can be connected to this to have a earth wire. Now we have plate earthing. The earth connection can be provided with the help of the copper or GI plate. Dimensions of the GI plate should be 66 into 3.18 mm. That is this plate, and it is buried into the earth. The plate is kept with its face vertical at a depth of 3 meter. You can see from here to here, it is kept at a depth of 3 meter, placed vertically, placed its face vertically upwards, and it is embedded in the alternate layers of coke and salt, or we can say charcoal and salt, for a minimum thickness of 15 mm. You can see we have a minimum thickness of 15 mm. We have the layers of coke and salt are providing around this so that its resistance will be decreased from here to here. Then a GI pipe is connected from here to here so that connection is taken to the copper wire. The earth wire is securely bolted to the earth plate with the help of bolt, nut and washer, and then the earth wire, that is this, is connected to the earth plate with the help of bolt, nut and washer. And these are also charcoal and something else, charcoal and salt, and water is poured from here so that this is continuously watered and kept moist. While kept in moist, the resistance will decrease. And the other thing is the strip earthing. This method of earthing is used while the earth bed have a rocky soil and excavation of the earth is difficult. In that case, we use the strip earthing. In this system, 5 standard wire gauge copper wire or copper strip of size not less than this 20 mm into 1.6 mm is buried in the horizontal trenches. So under such circumstances, earth resistance is slightly higher, of the order of 5 ohms. And the last one is the rod earthing. This type of earthing is done in sandy areas. In this method, earthing copper rod is hammered directly in the earth. This is the cheapest method, but again, earth resistance is high. So I'll stop over here. I hope you understood all these things.